this summer. Yeah. Do you guys remember what we saw in the summer packet for chain rule? Huh? No. Okay, I'm just going to write it on the whiteboard. We're going to see it soon anyway, but I'm just going to have it up here so that you guys can see. I don't remember if you guys did. Does anybody have their summer packet close? And those, like, the words at the end? Yeah. Chain rule in the summer packet. I know my notation in the notes, but I don't totally remember theirs. I remember they talk about an inner and an outer. Yeah, I think so. Is there any place where they have you state the rule? Is that the way they say it, though?
Oh.
Or is it like derivative of the outer? What's it say there?
For what types of
I think
the
somewhere
inner
says.
and outer and the derivative.
Oh, yeah. Say that again.
Label the following polymer presented in the video with inner and outer and the derivative.
Okay. So then, we're talking about composition of functions. Composition of functions, I should say. And you have an inner function that's been put in to the argument of the outer function. And the chain rule says, I don't remember if they give the notation in the summer packet. But in words, which we're going to write down in just a second, you don't have to put this in your notes yet, is derivative of the outer. Keeping the inner times derivative of, oh man, the inner. Struggle. There we go. Derivative of the outer, keeping the inner the same, times derivative of the inner. Kiddos, of the functions that you see, which one looks to have inners and outers in the sense of an inner function and an outer function, a function within a function? The ones on the left or the ones on the right?
The ones on the right.
Yeah, the ones on the right. Because the one on the left, if I was to say, who is this function of, pretty much the only thing he's of is x. Second one, sine of x, pretty much the only thing that he's of, even though they're not always written, remember, it's sine of x. The third one, pretty much the only one he's of is of x. And the fourth one, pretty much the only one he's of is of x. Now, over here, though, couldn't I say f of 3x plus 2? Or g of 6x? Or h of x squared plus 1? Now, this one's a little bit funny. The first piece doesn't have a chain rule. The first piece, the derivative is 1, that's easy. But the second piece, remember, with sums, we take the derivative separately. It'd be tangent of x squared. So let me introduce you to some notation. But first of all, quick reminder from the summer packet that there again, you guys just briefly saw it. It wasn't an in-depth covering of the idea or the rule at all. So a reminder, but also in some senses maybe learning for the first time. The chain rule can be applied when we're dealing with compositions of functions. And you guys remember compositions, right? F of g could be f of g of h, could be f of g of h of I, let's imagine j of x. So I'm writing f of g, but it could be f of g of h of, and keep on going. But I'm writing f of g. Now technically, we could go ahead and keep all of this in function notation. That's not necessarily bad. We could go ahead and keep these in function notation, meaning we could go ahead and decompose, and you might not remember that word from last year, but decompose meant to break apart the compositions, like peel them back and state who they are. We could on this one say f of x is equal to, he's the outer, and g of x is equal to. But there is another way of saying this, and so that's why I have this state u and f of u. We'll do that in a second. But if I was saying that each of these are f of x of g of x's, f of g of x's. Question, who would be on the inside of this guy? Who would g be?
3x.
Yeah, 3x plus 2. And who would be on the outside? What was he plugged into?
X.
Does that make sense? The whole on pause is kind of complicated. 3x plus 2 is what got plugged in. But when we go to make f, we say, oh, it was just x to the 5th. It was to the 5th power of the input of the argument of the x. Does that make sense, guys? Okay, go ahead and try to finish that. I want you to take each of these ones, and on this one, remember, just look at tangent, because x isn't a chain rule. He's just take the derivative of these one. But try to write f and g for the second three, or sorry, for the next three. I'm just going to write f and g to be ready. Who would you say is the outer? Let's go ahead and try all of them. I'll write out all of them. What do you guys think for the second one? What does your brain think of first? Who's G or who's F? Who's the inner or who's the outer?
I think outer.
You think outer? Okay, so you see a big old sign, right?
Yeah.
Okay, so sign of, but sign of who? Good. Then who's the inner?
6x.
I guess that makes sense with the next one too. Does your brain first see the square root?
Yes.
Who's that?
Square root of x. That's square root of x.
And that's F, right?
Yeah.
And then what took the place of X? Good. And then for the last one, remember, only looking at the tangent of x squared. And if it's ever written like this, you have to assume the parentheses are closing in the x and the square. You saw tan first? And then you saw x squared inside. Does that make sense? Now, I'm going to show you the other notations. The other notation isn't necessarily better. Just sometimes it simplifies a little bit when we go to take the derivative. I'm going to go ahead and change colors just so that you see we're not necessarily solving now, we're just looking at it a different way. So stating u and f of u. Another way of looking at this is stating f is the outer and u is the inner, which you wouldn't think would make a huge difference, but it kind of does. In that, you could say f of u is u to the fifth, and u is 3x plus 2. Does that make sense how this is really saying the same thing as that? This one's saying u is the inner, and f is the inner to the fifth power. Just a different way of writing it. This one, we don't really have to write f of g of x. This one, we'd have to write f of g in order to think about it. So if you're solving a rule and you're using the f of g notation, you can think about g is the inner, f is the outer. I'm going to show you how you can also think of chain rule using u is the inner and f is u to the fifth. So what would you guys say f of u is in the second one? Good. Sine of u. And who's u?
6x.
6x. Does that make sense? Okay, so keep going. Who's f of u of the third one? Square root of u. And u is? Good. Then the last one, just looking at the tangent, f of u is? Tangent u. And u is?
Wait, why would it the x just change? Why would it be still x?
Because the u is being hooked straight in.
Oh, okay.
So that will end up as your first function as y equals sine 6x. For example, the u equals 6x will replace the u in the sine.
Oh, I get that.
So this one shows the substitution.
Okay.
This one, you have to write the rule to see the substitution.
Yeah.
It's the other two different ways of doing it. One way says, hey, I want this guy. Okay, let me show who everybody is. This way says, let me just show it. That's the u, and it gets
That looks like more understandable.
this one. Yeah.
That makes sense.
Yeah, I think like it's going to be faster to do derivatives with this, but this comes back to the actual rule that's on the board. So that's why I didn't show you that. But let's go ahead and see if we can then kind of find the derivative using the f of u one. Because you already have seen the other one. We can actually put both on our forever card with f's and g's and with f's and u's. Let me show you the idea of f of u. So, if you're given f of u, and if we take the derivative of f of u, y equals okay. If I take the derivative, now the hard part is if I take the derivative right now, kiddos, and we haven't really done this a lot. Let's make a little bit of space. If I take the derivative of, do you guys see I'm getting ready to take a derivative? However, when I go to yeah, exactly. When I go to fill in, what's the variable that would need to go here? d du, right? So if I just took the derivative of f, totally disregarding the u. And what I mean by that is u is like x, so whatever is inside f, the derivative of the x is just 1. We would end up with dy du. It's just f prime of u. Does that make sense? If I took the derivative with respect to u, all I have is f prime of u. That would be it. But the problem is, our objective is not to find dy du. Our objective is to find the u is what I put in. What was there to begin with was an x. So I need dy dx. Well, isn't u going to be a function of x? I could put something like how do we show this one? Okay, so if I wanted, let's not show that. If I wanted dy dx, I can find dy du by just taking the derivative of f. That's fine. That's it. That's fine. Look at the outer function, take its derivative. That's fine. That's it. However, that would not be sufficient for actually solving my answer. Let me go ahead and use as an example. What was the one on the page before? We had the function y equals, was it 3x plus 2 to the 5th? Okay. This is an example. If I was to say, hey, let's think about this inner function as y equals u to the 5th, where u equals 3x plus 2. Okay? And if I was to take d du of both sides, all I have to say is, oh, hey, cool, what's the derivative of u to the 5th, guys? Well, that's easy, but what did I just get? But I want dy dx. I am going to plug into u, but I still have dy du. What would happen? What would happen if we derived the u, which I could do? Never mind. I could do because it's in terms of x. What would my notation be? Yeah, instead of dy dx, it'd be du dx. Oh wait, does this make sense? dy du times du dx would be dy dx.
Okay.
So what do I need
Plus you get derived u.
to find dy dx?
Get derived u and derived
Ready?
plus u.
Pause, let me make it easier, ready?
Yes.
Who is dy du? F prime of u, right? F prime of u. How can I shorten or make more simple d dx of u? U prime. So I take the derivative of f, keep the u, times the derivative of u. Hey, isn't that what's on the board? Derivative of the outer, keep the inner, times derivative of the inner. So I think of the inner as a u, take the derivative of what's outside, times the derivative of what's inside. So what am I going to do over here? To find dy dx, I
take that multiply by 3.
who's u prime? All I have to do is 3. Because I'm plugging into the rule, I'm doing the notation to get dy dx. So I think about the outer, I think of f of u and just take his derivative. Then I think of the inner and take his derivative, and it's a multiplication. It's not the product rule. It's a new rule called the chain rule. Now, I don't leave it like that because I don't see any x's, do you? Now, I can do 5 times 3 is 15. And who's going to be in here? To the... Dun, 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 dun. So I think about this, if you like the U notation, I think about this with u's. And I say this is u to the 5th. Okay, so 5u to the 4th times, and you're going to get very familiar with u prime. Because you're going to forget u prime. And you're going to get in trouble, because whenever you forget u prime, you're going to kill a bunny.
It's pretty important. Well, bunnies are going to learn before.
No! Rabbits too?
Exactly.
Was the U notation really important to learn for second
So,
semester?
This is the U notation. Tyler's asking if it's important. So let me show you the f of g of x notation. Huh? Yeah, it's coming. Okay, what if we were to take the exact same example? What if I was to solve it with what you saw in the summer packet? What's on the board? Y equals
3x plus 2.
what are the objectives? Or what is the objective? Find.
Find
Guys, this is a momentous day when you learn the chain rule.
It is.
It is. Okay, we could say
That day has passed.
f of x is, we already said this, x to the 5th. G of x is 3x plus 2.
Might be hard to identify the function.
We could say dy dx is equal to, well, hold on. We have a rule, right?
No.
Whoa. Hold on. Hold on.
Oh.
Bad. I didn't say take the derivative of. Bad. Okay. The derivative of y is, okay, ready? What's up there? F prime. Okay, who is F prime?
5x.
5 somebody to the 4th. Of who? Of g times g prime. Now, hold on. Some of these are going to be a lot harder than the mental math I just did. So, you would find who's f prime of x, 5x to the 4th. You would find g prime of x, 3. And then you would plug in f prime, this guy, plugging in that guy, times g prime. So f prime of g of x times g prime of x. Does this rule work also? And the answer is yeah. You get the exact same thing of 15, 3x plus 2 to the 4th. So we did it with u's. We did it with f's and g's.
Now let's do it with squares and triangles.
What if we do it now? Actually, I didn't need all that room, did I? This was using, did I actually write it? It's on the board, but if Sarah's watching this later, she didn't see it. Derivative of f of g of x. is f prime of g times g prime of x. We could do it with triangles and boxes, and we'll do that soon, but can I use words on the next one? Okay, so this one, we used this rule, f's and g's. The last one, we used u notation with f of u's. So then what's the next one going to be? Words. Words on the board, I'll go ahead and do it here. Derivative of the outer, parenthesis, well, I'll put it there. Keeping the inner the same, times derivative of the inner equals dy dx for composition. So, my same exact function. This one, in a way, is technically the one that will help you go fastest once you get the hang of it, but it can be hardest if you have an f of g of h positive. F of g of h, what does that mean? You have an outer and an inner, and an inner of the inner. This one's easiest for an outer and inner, and that's it. So if you have an outer and an inner of an inner, this one's kind of hard. But pause. Can you guys cover with your hand, or even mentally, just cover that up? And you see to the fifth power, right? Okay. So, how could I, hold on, pause. Look up here. How could I take the derivative of blob to the fifth? You could say box to the fifth. How do you do the derivative of that?
5 blob to the 4th.
5 blob to the 4th, right? Okay, so if I take the derivative of the outer, disregarding the inner, but keeping it there, keeping it the same, disregarding the inner, I would say 5 blob to the 4th. But because of our u's, because of our f of g of x notations, we know we can't just take the derivative of the outer. Take the derivative of the outer, bring down the 5, make it a 4, keeping the inner the same, but what else do I need? Who was that? That was u prime. Who is that? G prime of x. Who is that in this one? Now look at the inner, ignoring the outer. Same thing as the others. It's like a simplification. And it's not too bad as long as you have one outer and one inner. Okay. Let's get down our further.
If you had 2 like inscribed functions, or so if you had like f of g of h of x, wouldn't it be easiest when you got to g prime of x? Can you do chain rule again? Right?
It'd be g prime of h times h prime. So it'd be f prime of g of h times g prime of h times h prime. And if there's another one, you just keep going.
I think it's messy after 3, but
Yeah. So the nice thing is we've already practiced all 3 of these ways. We've already practiced all 3 of these ways.
what forever is this?
I think it's
14, right?
14. Yeah, it is 13 or 14. 14, I think. Was the trig one 13?
Yeah. Okay, 7, 14. That's why it really helps.
Oh, good. I need to update that though. Sorry. Oh, on 13? Was the tangent secant one? That was 12?
13. 12 was the what? But I have a 13.
Oh wait, the tangent secants. That's what you guys are missing.
Yeah, that was 13. No, I had it.
Oh, I got it.
Did I not mark it in here? This one.
Oh wait, yeah, no, sorry.
No, you're okay.
It's right here.
Yeah, so
If you get off on your count, it's really sad. That's why I was just apologizing to David because I haven't updated the slides on mine.
And you have all the wrong
I need to update that
numbers,
today.
and then you blame this E, and then everything goes down.
Now, this little bottom part is just like a,
Ooh.
oh, is it tied? Okay, hold on. The what if, that is not in the forever card. Hold on. That's like a, what if we have an F of G of H? And I've already kind of been prepping you guys for that. But that's just like a, oh no. Here, I'll put my box now. Oh, that's lame. Okay, so the box goes around everything up until the wording. Okay, for those of you guys that like the boxes and the triangles, this one gets kind of hard to show that notation. It's not impossible, it's just kind of hard. Instead, what I would probably do is not make it totally with boxes and triangles. I'm going to put this outside the forever card. This is card number 14. Thanks for figuring that out. What you could think of is the derivative of f of box is f prime of box times box prime. I could almost do like, well, I haven't really liked this notation. I'll do that. You could almost do like a triangle and have triangle prime with a box inside times box prime. The reason I don't like that is I don't know if it totally gives you the idea that you're only taking the derivative of the triangle and not the box. Like that's why I tend to get, I don't like that notation as much. I'd rather you think of it as f of box is f prime of box times box prime. And if there was a triangle inside, f of box of triangle would be f prime of box triangle times box prime of triangle times triangle prime. Think of it like that. It just gets a little messier for f of g of h. So what if down below is what if we did have an f of g of h. Did I just show you guys my Matryoshka doll yesterday?
Oh.
Why would I show you this?
Because they're composite.
They're like compositions, right? You have an outer and then an inner, but you have an inner in the inner, and you have an inner in the inner and an inner. Did I say too many?
Matryoshka.
Matryoshka. So I could have an outer with an inner 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 with an innermost. Okay, so. Ooh.
You have them.
Who's empty? I don't have a super nice one. Someone goes to Russia.
Let's see who's scary. I used to have so many because my friends went to Russia.
Something did last year.
They are cool. My dad had somebody went to Russia and got him because he's a history teacher. Got him like all the presidents. It was really fun. It wasn't like all 50, but it started at like Clinton because he was the president at the time, and so then it went back. They were like painted and everything. Okay, this would be F. Okay, so when I'm taking chain rule, I take his prime, just who I see, his prime. But am I taking anybody out? No, just his prime. Keeping everybody the same. Times, now what do I do?
Remove them.
His turn. His prime. Keep everybody the same. Times, if I need to, who would be next? His prime. Keeping everybody inside. These guys are out. You peel them off every time. But what if there was another inside? His prime.
What the heck?
His inside. And then, his prime. Oh, he's not colored. His prime. It's actually her. Sorry. Her prime. Keeping.
Please don't. Oh, there's none.
Wait. Pause. When you get to the last function,
There's an X.
who would be the inside? Just X. Wait. What would X prime be? Ah! You're done. You get to keep on peeling until all you have left is an X and the derivative of X is 1.
Oh my god.
So technically, maybe we were doing F's of G's of H's back here. Because we could have said that the outer was f, x to the fifth. The inner was 3x plus 2, and the inner was x. Could we have said that? We could have said f is x to the fifth, g is 3x plus 2, and h is x. And what we would have done is exactly what we did. We would have taken s prime, 5x to the fourth, with g of h plugged in, which technically is the 3 something plus 2 with an x in there, times, peel off the fifth, now it's his turn, times, what's the derivative of 3x plus 2? 3 times, peel off the 3 and the plus 2, what's left? X, and what's his prime? 1. So we can technically actually even make an f of g and f of g of h, but let's go ahead and see what happens when we have a real f of g of h without an x.
Yes.
Oh, that's no fun. We already did that one. Never mind.
I'm gonna find one.
If you wanted, you could do the square root of.
You just have a little
Oh, it's not even a fun one.
Yeah, you could do like sine of 6x squared.
Where's our f of g? Oh, here he is. Woo! There you go.
Yeah, that's fine.
So
You're mad at us, Miss
tangent.
No. I'm here to help.
Or sorry, your outer is x.
Now, if I gave it to you randomly in homework and didn't warn you for it,
And your inner is x.
I don't get mad very often.
Miss D, is that right? Your outer is x.
If you want, you can write down what you think it would be. Pause. Now, this one's trickier because it's trig notation. Don't get tricked by the trig notation. This one's trickier because it's trig notation. So let me help you out really fast. If you ever have a trig raised to a power, the very first thing I need you to do is rewrite them. Because the little fourth next to the tan is shortcut notation for the whole tangent being raised to the fourth. Why do I write it like that? It's so much easier to see the outer. So when you see tangent to the fourth of x cubed, the very first thing I need you to do is rewrite. The very first thing I need you to do is rewrite it as the trig of the argument all to the power. Okay. Now, I'm trying to think of which rule to use. Let me use kind of all of them. Alright? I'm going to kind of just split my page into thirds. This one's going to be my u, my f of u notation. This one's going to be my f of g of h notation. And this one's going to be my words. Sorry, it's cold in my hand. Okay. Ready?
Yeah.
To find the derivative of all of these, my objective once again is find dy dx, right? To find my derivative of all of these, I have to take it one step at a time. So on this one, I would say my f of u is u to the fourth. Do you guys agree?
Yeah.
Okay. My u, my u is tangent of v.
So that makes sense.
Because, yeah, right? X cubed. I can't make it x. I have to make it somebody else. So if u is this guy, then v must be that guy. He's the inner Matryoshka. He's the inner function. And then what's my v? Oh, so I had to. I'm just using the alphabet. Q, V, W. You could have a W too if you had an F of G of H of J.
Okay.
Which we probably won't.
Now, the rule says take F prime, now if you guys want, you can technically think of it as. No, we can just write it like this. That's okay. Okay. It's going to be F prime of U times U prime times V prime. I have to do all of them. So who's the derivative of the F one? Yeah, 4u to the fourth. No, third, thank you. Ooh, that was rough. What's U prime going to be? What's the derivative of tangent?
secant squared x.
Yeah, that's the one we keep studying. But secant squared of, but not x. Who's in there?
Oh, v.
V. And who's v prime going to be?
X squared.
Now pause. I don't want using v's in my answer. What do I want? All in terms of x. So then work backwards. I have my 3x squared. I can combine with my 4 to be 12x squared.
Wait, why don't you just
Oh, never mind. Never mind,
start
too
going
fast.
backwards?
Let's answer, too fast. Okay, so I have 4 times, I wasn't done yet, but I apologize. Who's u? Tangent of v, right? Tangent cubed of v. Can I put the cube back in? Is that okay?
Oh, why are we going back to it?
Well, I have to plug in u, right?
We have to.
The U notation is a little clumsy for this, I would imagine.
We can't have u's and v's, so we're changing everything.
So first of all, I got rid of my u by plugging in tangent v, and now what am I going to get rid of?
The v.
My v's. So I'm going to have 4 tangent cubed of x cubed secant squared of x cubed times 3x squared.
Okay.
I had to plug v in. I had to plug in v. I had to plug in v. And now just make it look pretty. 4 gets to combine with the 3x squared. I usually move everything in front of the trig if possible. Same thing as a square root. Move everything in front of. So I'm going to have 12x squared tangent cubed of x cubed secant squared of x cubed. So the u had to get plugged in first, then the v's had to get plugged in second.
Oh,
That
now
kinda
we
makes
do
sense?
12x squared first.
Yeah. So I was starting to simplify, but I just realized it was way too fast for you guys. I'm sorry. The 4 and the 3x squared. Yeah. I went ahead and moved those in front because they were the non-tricky ones. Today's not a special schedule, is it?
Oh,
Do we have pep rally? That doesn't make sense.
That's only 2 years practice. Oh, probably the football game too.
Let's do it. What's the answer?
Come on, guys, give yourself 5 minutes. Give me a second.
Oh, I showed time, right?
Hold on. I don't know. I did not see.
I don't know. People are confused.
Hold on. I know they are. I know they are.
It's middle school
I don't want you guys to have 5 minutes less.
Who's leaving? What?
It's a regular schedule day. It's a regular schedule day.
People want to know.
Well, why would they have a separate first? Wait, did anybody get the answer?
Okay, is there a way we can make an announcement? Alright. Alright, thanks. Alright guys, we still have 5 more minutes.
Oh, Mr.
Okay, hold on. I want to solve it the 2 other ways. That's what I'm really trying to do this.
I don't understand.
Are we allowed to leave?
Don't, yeah.
No, they're gonna make an announcement. Class isn't over, we still have 5 minutes.
Okay, thank you.
You're welcome. Okay, pause. Did you guys see how I took f's prime, 4u cubed? I took u's prime, secant squared v, and I took v's prime, 3x squared. Could I have taken x's prime to be 1 and been done? Yes, but I didn't need to. So then, I have my 4u cubed, my secant squared v, and my 3x squared, and then I just need to substitute. So I said, who is u? I'll plug that in first. Then I said, who is v? Plug that in second. Simplify.
Okay. So you went back to the original,
I went back to my statement of who's who.
and then you were like, okay.
Because I already did my primes, I just needed to plug in. Because my trig is just of this guy. So this is separate. I can rearrange multiplication. So I rearranged this guy next to, and then I was able to go and put them together.
And do you have to have parentheses on the x?
Not exactly, but the cube and the cube look really confusing. Now, can I try the f of g of h?
Yeah.
Okay. For the f of g of h, f is x to the fourth. G is tangent of x. H is x cubed. My formula would say f prime of g of h times g prime of h times h prime.
Whoa.
It's the formula, just expand it, because I have to do outer, keep the inner, outer, keep the inner,
Yeah.
inner
It's a
prime.
lot easier.
But no.
F prime of g of h, g prime of h of x, and h prime of x. So then you would have for somebody cubed, and the somebody would be the g of h, which would be tangent of x cubed. And then g prime is secant squared of h is x cubed,
What's the last part?
h prime of x. And then h prime of x is 3x squared.
Times each
Mm-hmm.
Oh, so we did get it right.
So then
It's just messy.
that'd be 12x squared tangent cubed of x cubed secant squared of x cubed. Now, let me do the words and then we'll see if we have questions.
That's for 3x today.
3x squared. Okay, the words. I have blocked to the fourth. Okay, I'll wait till you guys catch up. I have blocked to the fourth, right? Okay, how do I take the derivative of block to the fourth?
Fourth block 3.
Derivative of the outer, bring down the fourth, keeping the inner the same. Bring down the 4, make it a 3, keep everything else the same. Now, I peel the fourth off, the matryoshka, I take that outer shell off. Who's now in here? Tangent of block. What's the derivative of tangent block? Secant squared block. Peel off the tangent. I've done the fourth, I've done the tangent. Who's left?
Block to the third.
And what's block to the third? 3 block squared. And what is block prime? Just block. Okay.
It makes so much more sense when you say blob.
Yeah.
I don't know why.
Oh.
When you say blob, I don't know.
It's so nice and clean. You don't have to work. But
Or the
Misty,
count thing.
But so many mistakes get made in this process, but if you can get to the point where you can do the words, oh man, look how much work you can do. Okay, kiddos, we've done great examples. Homework is going to be due on Tuesday. I'm going to have to take another day on payroll. It is what it is, but you've seen the easiest to the hardest already. We just need to practice like we did with the basic rules to make sure we're okay with it. Okay, start homework. Happy Friday.
Misty, if you don't use later on, will it become cumbersome and slow you down immensely?
Not necessarily, but the AP can give you questions where they use F's and G's, or they use U's, and you just need to know what to do with them.
So you basically